the problems where we're going to do a lot of word problems that deal with navigation. All right, question number 2 deals with basically graphing and describing everything. So here we have a sine function, and to graph the sine function, we need to understand the parts. So let's go through the parts of the sine function. B times x minus c plus d. All right, so one of the things when we teach the graphing trigonometric functions, at least in my class, I tell students, how does A impact a graph? How does B? How does C? How does D? So A basically obviously is the stretch and the compression of the graph. It also reflects the graph about the x-axis, but it also tells us about the amplitude of the graph. And that's basically going to be how high and how low the graph goes without any vertical transformations. Or a better way to say it is really what is the half distance between the max and the min of the graph. However, when we have an amplitude, the definition of the amplitude is the absolute value of your A. So in this case, it is just 4. My B changes the period of the graph. Basically, the period, again, is how long it takes the graph to repeat itself. Yeah, I got a little super. I don't know why that showed up. That's so weird. Caesar, I appreciate you. You gave me a super chat last time. Do you watch Mr. Beast's new video? I did watch Mr. Beast's new video. Sorry, I had to break it up. I didn't want to do this. But I'm actually, I'm in a lot of new things. I actually had a new video, sorry, I just had to break it up, about like trees and the 20 million trees and everything like that. And it was one of the things I was kind of a part of as far as like the donation and before you guys even knew it as alive and everything like that. And I'm a part of that circle. That a lot of people were all talking about this and letting it know that I was going to go live, but I ended up not doing a math video from that. But I did see that. So Caesar, I do think that is an excellent cause, especially once I looked into a lot of the trees, and it's been really cool to kind of see how that has taken off and how much publicity that has grown. So, or how much publicity that has grown. So I think it's really cool from that. And again, thank you so much for the super chat. I really do appreciate it. So the period for sine is going to be 2 pi divided by b. Well, in this case, my b is 3. So my period is 2 pi divided by 3. Our phase shift is basically going to be how far is the graph, shifting left or right. And therefore, you can see since you're adding pi thirds, that's going to be pi over 3 to the left. And then my vertical transformation is basically how far am I shifting my graph up and down. And you can see this is going to be down 2. All right, so to understand actually how to graph, and again, this has been a while. I haven't done this in, I don't teach this really in my class anymore. But the main thing is to understand what the initial form of the graph is. So let's go over the parent graph of sine. Okay, so we have 1, -1, and 2 pi. All right, so this is what we call the initial period of sine. It goes up to 1, goes down to -1, and it completes a whole cycle within 2 pi. All right, so it starts at 0 and it ends at 2 pi. Now, if we wanted to graph this, now again, typically what we do when we are graphing is we want to graph like 2 periods. And what we can do though is let's just focus on like 1 period for a second. So what we're going to do is, what I like to do is what we call the start. So what we're going to do is we're going to take everything inside of the function and we're going to set that equal to 0. So 3x plus pi over 3 equals 0. And then we're going to do the end. So obviously the initial period ends at 2 pi. So again, we're going to take everything and then set it equal to 2 pi. So that's going to be based on the transformations. Because again, remember, inside of the function shifts the graph left or right, right? So anything outside of the function, the 4 and the -2, shift the graph up or down. They are not impacting the graph left or right. So what I want to do is I want to determine where the new start and ends are of the graph. The other thing I want to do is also determine the x scale. And the x scale basically, if you look at this graph here, obviously we have the endpoints, like the beginning and the end. We have this kind of midway point, and then we also have the max and the min. Like those are kind of important points of the graph. So it's kind of helpful to kind of know like where those points occur. Now, obviously, this occurs at pi halves, and 3 pi halves. All right, so let's go ahead and the way to determine the x scale is basically going to be the period, whatever the period may be, over 4. All right, so let's go ahead and get this all set. So you divide by 3 here, and then we have x plus pi over 3 equals 0. So x equals negative pi over 3. The end, you're going to divide by 3 and then subtract. So divide by 3. So then we have, let's do this, pi over 3. Oh, I'm sorry, hold on. Yeah, so you have pi over 3 is equal to 2 pi over 3. So I'm sorry. Divide by 3 on the outside, you have x plus pi over 3 equals 2 pi over 3. All right, so if you subtract pi over 3, that means x is going to equal a positive pi over 3. Interesting. And then our x scale is going to be 2 pi over 3 divided by 4. This always got students, it's been a while since I've done this. This always got students messed up, was multiplying by the reciprocal, which becomes, that divides out. That becomes a pi over 6, which is the same thing as a 2 pi over, trying to think, pi over 6, which becomes a 2 pi 6 over 12. That's not going to really help with that. Pi over 6. I was trying to think of pi over 3. All right, so either way, let's just kind of forget the x scale. That's not going to be any, well, 2 pi over 12. I don't think that's going to help out. All right, so let's go ahead and get a rough sketch. So we have pi over 3, or negative pi over 3, is now the new start. Instead of at 0, 0, it's now at negative pi over 3. And then we have at 2, or at pi over 3. Okay? Now, there are a couple other things that are going on. Not only, that was just a shift left to right. In addition to this problem, which is like not a very basic problem, the graph also has an amplitude of 4. That means it goes up to 4 and down to negative 4. But the graph is also being shifted down to. So originally, without any vertical shift left or up or down, it went as high as 4 and as down as 4. But then once it gets shifted down to, now the graph only goes as high as 2 and as low as 6. So 1, 2, 3, 4, 5, 6. All right. So basically, this is going to be your midpoint here. So I'm just going to kind of, and actually we can kind of recognize that this is going to be negative pi over 6, and that's going to be pi over 6. So my graph is going to go, it got shifted down to, so then it's going to start down here. That's going to be my max. That's going to be my min. And there you go. There's a oh, no, that's wrong. What happened here? That's going to be your max. Oh, that crosses there. My bad. Disregard that. Okay. So it starts at down to. That's correct. That's going to be your max. That's going to cross. That's going to be down. There you go. And that's going to come up. Now the graph is bad, obviously, and I take full credit for it. It's been a while since